Yeah. So I think did we go to like statistics on the graphical calculator,
Yeah.
and then did we press distribution when we got to it?
Let's see. So statistics. Yeah, distribution.
And then was it binomial or something?
This one says. Does it say it's explicitly anywhere? So this N stands for normal. X is normally distributed.
And okay,
And so from there, I need to help you because this is new. Well, if it's normal distribution, you're never going to do probability. It's always going to be cumulative, I believe.
yeah,
Um, we want, this time we're given, oh, hang on. I don't know. Let's just do normal. Let's just do normal cumulative distribution. Okay, what can we put in?
so am I putting in? So 115 squared. I think one of those numbers was the mean.
Do you remember which one?
Is it 15?
Nope. 100.
So I'm putting 100 as the mean.
Yeah.
And the other one was like the standard deviation.
Mm-hmm. So technically it's the variance. Standard deviation is the square root of it, but square root of 15 squared is just 15.
Okay. And now I need to put in numbers for lower and upper, don't I?
Yeah.
I don't know. Do I need to put like lower 0, upper 140 or something?
I think, so they said the probability that they're a genius, that would be 140 or more.
Yeah.
What is this thing doing?
Oh, so would it be lower as 140?
Yeah. And so upper.
Like 999?
That's what I do. Okay, and so we get our probability.
Yeah.
And find the probability to 3 sig fig. Okay, what's that?
For me is 3.83 times 10 to the minus 3.
Yeah, and so just so it's a bit more, well, hang on. So part A, 10 to the minus 3, that's 3 zeros, and then 383, and don't forget the decimal. Or to make it a bit kind of more normal, maybe I shouldn't do this, a bit less weird, is times it by 100. So it would be 0.383, and that's percent. So you can write it as a percentage. So it's not standard form or anything. Then we have to do this, part B.
Okay, so 20 adults take the test. Five probability that two or more are classified as genius. So, um, do I need to do something like 0.00383 times x equals to something?
Well, that's a lot of something, but
Yeah.
this is the tricky bit. Either they're a genius or they're not a genius. How many wheels on a bicycle?
Two.
This is binomial. Either they're genius or not. So we exit distribution binomial. If they wanted 2, that would be probability distribution. They want 2 or more, So cumulative. So we don't have to add them up. So what are we doing for this one?
They said 2 or more. Does that mean that lower is 2, upper is 999?
Not
Oh no,
999.
it's upper is 20.
Upper's 20. Yeah.
So after 20. And then do I just press enter again?
No. Number of trials? That's like n.
Oh, sorry, I'm non-binomial. Sorry, so I need to go distribution.
Yeah. Exit distribution binomial.
Binomial and binomial cumulative data.
Yeah.
Yeah. So number of trials. I'm assuming once.
No. It's like n. In this case, it would be people.
20.
Yep. And probability.
Is that like the probability that they are, or
Yeah.
is that
Probability.
like 2 over 20, or
Now, what was the probability that someone is a genius?
is it 0.00383?
Yeah. And I'm going to do it to 5 sig fig because we're using it now. 0.4. Yeah. And so, what is this one?
So yeah.
This one? So 0.00266. Let's see. 0.00286. I thought it'd be smaller. 286%. Hope that's right. There we go. And yeah. And so this one we had to well, let's just recap. So x is normally distributed, so it's normal distribution. It's always going to be cumulative for normal distribution. The adult gets 140 or more. So first number is mean. Second number square rooted to get standard deviation. It's like deviation squared. 140 or more. So lower is 140, upper 999. So that's the probability of one adult getting 140 or more. We wanted the probability of 2 out of 20 getting 40 or more, and so that was binomial because they either get it or they don't. And so let me show you. It could have been what's the probability of between 2 and 7 people. So that would be a lower of 2 and an upper of 7. But n is 20, the total. For our first one, it's a bit like mu. It's a bit like mean for normal distribution. Yep. Any questions there?
No.
Okay. And this is something that they like to do a lot. Okay. Yep. Let's try this.
Okay. So am I doing am I just doing the same thing with the calculator?
Yep.
And so now will I put like 90 lower, 999 upper?
So is it normal or binomial?
Is it normal?
Yeah.
Well,
So normal, cumulative. So what was it? Lower was 90, upper 999, is that what you said?
yeah.
Yeah.
And then mean 80,
Yep.
variance 12.
Deviation 12 or variance
Yeah.
12 squared. Yeah.
Yeah. And I got T is 0.202.
Okay. Oops. Next one.
And then if we go back, so if I put lower as, or even if I put upper as 65 and put lower as 0,
Mm-hmm.
and then the same thing, that will give me probability of 0.1.
Okay. And part B.
So is it now going to be normal binomial distribution?
Yeah. We need the probability of less than 60 though.
So mean is 80.
Uh-huh.
So there's 25 students taking the test. Does that mean that on average they'll be getting 80?
Doesn't really matter.
Yeah, I'm trying to find. Yeah.
We need the probability first.
So the probability was. Oh, do I need to now just sub in 60 instead of 65?
Yeah.
And so that will be 0.0
4779.
yeah.
Yeah.
Okay. And so now if I go to distribution binomial cumulative distribution, do I now need to put in lower 0, upper 60, number of trials?
No. Slow down.
Yeah.
What's upper and lower?
Upper 60, upper 60, lower 0.
No. Lower will be 2 students. If it's, oh no, sorry, 3 or more. So I believe the lower will be 3. An idea about upper?
25.
Yep. Number of trials?
25.
Yep. Probability?
0.04779.
Yeah. So let's see. This will give me an answer. No, 0 point. And put in like 5 sig fig. 4, Yeah, 7790. Yeah. So what do you get there?
0.115.
Yes. And so that's like 11.5%.
Yeah.
And so what's this thing about? If we wanted to do part B, you might think we can just go straight to it. They either pass or fail. Like they either pass or don't pass. And so it's binomial. The lower would be 3, the upper would be 25. N is 25, but the problem is, what's the probability of getting 60 or less? And so we had to do that using normal distribution because the pass rate thing at the beginning is normally distributed. All right. Any questions about that?
No.
And so you can see it's a common enough question where part A, normal distribution, part B, binomial. And you have to know that you swap between the two. And there we go. If that number is correct, and all the other ones are correct as well. Let's see. Let's see this thing. 460. Ah, yeah, it's worth doing, unfortunately. Okay. How about this?
Okay, so am I doing binomial again?
Let's see. First one isn't binomially distributed.
Okay, so
It's got that n.
and so if I then mean 454, deviation 5.6.
Okay.
Lower 460, upper 999.
Yep.
And I got 14.2%.
Mine gave me the old one. Okay. Part B.
And so
Is that not working?
so am I just gonna do lower 452, upper 458,
Yep.
and then yeah. I got 0.4.
Okay. And part C.
Okay, I think now I need to do binomial.
Yep.
So I'm adding lower 15, upper 18.
Yep.
So I put lower 15, upper 18, num trial 18, P 0.04.
Okay.
So it's probably wrong because I got 1.1. Oh no, it's not. It's times 10 to the minus 17.
So what were your things for this one?
15, 18, 18,
Yeah.
and then 0.04779.
No, that's just your previous answer that you had from the previous question.
Yeah.
What is the probability that they pass the test? That one jar passes the test.
10, is it like 1 over 18?
No.
I don't know.
Which question had something to do with passing the quality control test?
B.
Yep. And what was the probability of passing the control test?
0.4.
Yep.
So, okay. I put it in, shall I put the answer? Shall I now check the answer?
Yep.
And I got 2.2933 times 10 to the minus 4.
Did you do 0.4 or 0.4019825 sig fig?
I did all of the numbers.
Okay. And what was your answer?
2.2933 times 10 to the minus 4.
Okay, so yours is a bit more accurate than mine, but mine is accurate to 3 sig fig. They're both the same to 3 sig fig. Great. You make me do even more of these questions. I don't want to.
So,
The what was it? The probability that this binomial thing that we do at the end, that's they either pass or fail, and so it's what is the probability that they pass? Probability that they pass we got in part B, and so that's what we're using there, and that's why we did that part B. What was our answer for this one? Yeah, 0.00002, and that's what they have here.
by the way, when doing binomial distribution, is the num trial always the same as the upper?
No. That's just because they're saying 2 or more. It's like this part B, how with normal distribution, it was in between 452 and 458. So if they had asked what's the probability that between 15 and 17 pass, then the lower would be 15, the upper would be 17, and the n would be 18.
Okay.
It's between 15 and 17 out of 18. And because it's cumulative, they're just finding the probability of 15 plus the probability of 16 plus the probability of 17 plus the probability of 18. But they're just doing it in a very, calculator's doing it in a very quick way.
Yeah.
Very quick. Let's see this one. Yeah, you're making me do another one of these. All right.
Okay, so. Okay, so this is going to be binomial normal distribution. No, sorry, normal cumulative distribution.
Mm-hmm.
And so mean 13, the deviation 0.1, I think I'm doing lower 0, upper 12.8.
No. Wait. Yep.
Okay. And so I got 0.02275.
Okay. Part B.
And so now okay, that's okay. So I think now I need to do binomial cumulative distribution,
Yep.
and I think am I doing lower 12.9, upper 13.1. Um,
What problem are you facing?
I feel like I should have an extra option. I don't know.
What binomial did you go into?
Cumulative.
Yeah. So what are the other two things outside of lower and upper?
Pardon, sorry.
So what are the other two things? Does it say num trial?
Yeah.
What is num trials? Number of trials.
40.
Yep. Let's see. But no. Because what is probability?
Is it just the previous probability you just found?
That was the probability of 12.8 or less. We need the probability of between 12.9 and 13.1.
So shall I go back and do the number cumulative distribution with 12.9 rather than 12.8? Or
Yep. So you need that probability for your binomial.
yeah. So am I doing upper 12.9, lower 0?
That's not possible.
Oh, 999.
No. When are bolts considered perfect?
When they're between 12.9 and 13.1.
So what's lower, what's upper?
12.9 lower, 13.1 upper.
Yep. So that's what we're doing.
And so I got probability is 0.68.
So that's the probability that a bolt is perfect between 12.9 and 13.1. So now we want probability that more than 25 out of 40 are perfect.
And so now if I do lower 12.9, upper 13.1, num trial 40, probability 0.68.
Yep.
Yeah. So I got 0.83.
Yep. Great. And so you find, so the probability that they are perfect is normally distributed with a mean of 13. Standard deviation is 0.1 between 12.9 and 13.1. So you get the probability that they're perfect, and then you use that for binomial distribution. They're either perfect or they're not perfect. 25 or more, so lower is 25, upper is 40, total is 40, and the probability of them being perfect is 68.3% roughly. And overall you get 83% roughly. That in a batch of 40, 25 or more will be perfect. We got 83 or something, did we? Wait, what? What the what? What the what? Find the probability that the bowl chosen at random has a diameter less than 12.8. A suitable lower limit is 12.5. Okay. Hang on. So what was it? What was our first one? Sorry.
I don't remember.
I have it in here somewhere. 0.0227. Yeah. That was fine. So then between 12.9 and 13.1, we got 68.3%. 40. Hang on. Find the probability that more than 25. Why would they do that to us? It's not 25 or more. It's more than 25. So what's that going to be?
Is that just 26?
This is 26. Yeah, well done. Well done. You're so clever, Mr. Bookman. Making everyone get the question wrong.
And yeah, I got 0.734454.
Alright. Okay, any questions about that?
No.
Okay. Let me just get that right. Let me see. The height of athletes. I'm not doing that. That's okay. That's okay. It's just you get two easy ones and multiply them together, I think. Find the probability of the squirrel. How's that? Squirrels. Alright, let's just do part B.
Okay, so find probability that at least 15 will score. So do I need to do normal cumulative distribution first, then use the probability for that to do not binomial?
Yeah.
Go to distribution. And so if I do so lower 470, upper 490, mean 480, deviation 40. My probability is 0.1974.
Okay. What's next?
And so now, if I go to binomial distribution, I do lower 15, upper 30, non-trial 30. Probability 0.1974.
Yeah. Put in 1 at the end.
Yeah. And I got 1.9871 times 10 to the minus 4. Yeah.
Okay. And let me just make sure about this. I think it looks good. At least 15, so that's 15 or more. Yeah. 199, and ours rounds to 199.3 sig fig times 10 to the minus 4 or whatever. Great, you did it all by yourself. Good. Okay, that stuff, you're good. Next stuff. Inverse normal distribution. X is normally distributed. Mean of 20. Standard deviation 3. X is less than something is 75%. What is that something? Any idea about that? You're not gonna get it. You're not gonna get it. Hold on. This time. Exit. Distribution. So it's normally distributed. This time we want inverse normal.
Yeah.
The tail. It's less than. Any idea what way the tail's going to
go? Left.
Yep. So less than. Probability is represented by area.
And so is that 0.75?
Yeah, we want a probability of 0.75. Other two?
3 and 20.
Yep.
And now I just need to just put enter.
Yep.
I got 22.02.
That's it. And what that tells you is if they asked you, like, what is the probability that this bolt is 22 millimeters or less or whatever, you would get like roughly 0.75. And so now you're just working in reverse. They give you 0.75 and you have to say what X, this or less would give you. So it's a bit like if you put in lower is 0, upper is 22. And it makes sense. The mean is 20. So let me just put in 20. I can't, can I? Well, if it was a mean of 20, what's the probability of 20 or less? It would be exactly 50%. Here, what's the probability of 22 or less? It's going to be more than 50%. So in this case, 75%. So it's just working in reverse. Okay, next one, B.
Okay, so now I'm assuming, is everything going to be the same except that the tail is right and the area is 0.4?
I believe so. Been a while since I've done these.
So
it should be.
I got 20.76.
Yep, looks good. And C.
Okay. Will tail now be central?
Yeah, that's a good point. Tell me something.
And do I?
So actually, maybe tail isn't central. Yeah, I don't like that central tail business because that means it's perfectly symmetrical. It's not very common.
Okay.
All right, now we have to actually do some work. Finally. Let's see. Part C. The
Oh,
probability.
am I just gonna have to separate it out twice or something?
I believe so. Yeah, go on.
So would I first of all do tail right and then area, or not even, or actually, yeah, fine, area 0.3. I need to find some sort of way to incorporate the 16. Not sure.
There will be. Let's see. So the probability. So this is going to look like this. So you have a mean of 20. Why? This laptop. Come on, man. Okay. There we go. Okay. So 16 is here. Let's just say A is there. I don't know where it is. And so we want this, but we're told that this in here, oops, we're told that this in here has an area of 0.3. And so we need to say what, we have the lower, that's 16. We need what upper would give us overall area or probability 0.3. One way you can do it would be the probability that x is less than a would give us 0.3 plus this little extra bit.
Yeah.
And so we subtract the probability that x is less than 16 because that extra bit is the probability that x is less than 16. That's how you incorporate the 16 bit.
Okay. So am I now doing tail left?
Yep.
And area 0.3. And I got probability 18.42 for P of X is smaller than A.
This would have to be regular normal distribution, cumulative.
Okay.
16 less. I'll just be a sec. Sorry about that. Did you get probability x is 16 or less?
So up to 16, lower 0. Yeah, I got 0.09.
So, well, let's say 5 sig fig.
0.09121.
That's 4 sig fig.
9121 1.
Yep. And so the probability that x is less than a minus that gives us 0.3.
So I just do 0.3 plus that then.
Yeah. So that's 0.391211. And so how do we now get a?
We now go back to
Yep.
Inverse distribution, do it, yeah. And so I do tail left area 0. Oh, will area just be the probability? So
Yep.
391, etc.
211, I think it was. I put 0 instead of 9. This thing. I don't know how to use it. There we go. 0.391211. Is that what you get? This thing. What did you get for this one?
Yeah, I got 19.17.
Sorry, my laptop's just broken. Just broken. Come on, what do I have to do? Capture screen. we go. Put that there. And so we believe it's 19.223 sig fig. And so this is what they look like. And there we go. 19.2. Okay, so I thought it was on the other side of the... I sketched it as being like over here because I didn't know any better. It's actually less than the mean. Let's see. So, yes. Lower, minus 9999. So for this one, we have to... if you have in between the two, that's the tricky one. So it's the probability of the right one minus the probability of the left one. Overall gives you that probability, and then you have to work in reverse, adding it and stuff. All right. Let's see. Oh, wow. Hang on. Are we just going straight in, is it? Yeah, it looks like we are. Yep. Okay. Let's try this.
Okay. So okay, so does that mean that the probability of less than x is 0.6?
Yep.
So is that like x is smaller than, or yeah, d is smaller than x, sorry.
Okay, what is x?
So if I go to inverse normal distribution, and then put area 0.6, tail left, or even, yeah, tail left, I think. And then mean, or even deviation 1.5, mean 20. And should I just give what the inverse normal answer I guess?
Yep.
Which is 20.38.
Great. Part B.
So get the interquartile range. Would I need to now make the tail right and then subtract both answers from each other?
That's not how interquartile range works.
So do I need to find like the mean first?
No. Interquartile range is what?
Upper quartile minus lower quartile.
Yep. What's upper quartile? How do you get that? How much of the data is that?
3/4.
Yep. Or as a percentage?
0.75.
Yep.
75%. Yeah.
Yep. So what x gives you 75%?
Is that like 75% times 0.6 or?
No. It is. If I just go to these ones, 75% would be like whatever x gives you 75%, And then it would be minus whatever x gives you 25%.
Yeah.
And so what you just found was an x that gives you 60%. We want an x that gives us 75%. How do we do that?
So we had to like do or we have to subtract two probabilities from each other.
Okay, you need two probabilities first. How do you get the x that will give you an area of 75%? You just found an x that will give you an area of 60%.
So do I literally just put in d is smaller than x equals 0.75?
Yep.
Okay. So the area is 0.75. I got 21.011.
Makes sense. It's a bit bigger than the mean, which was 20.
Yeah.
Okay. So that's 21.012. So that's the upper quartile.
And so now do I put for area 0.25?
Yep.
And I got 18.988.
Okay.
And so now I just do 21.012 minus 18.988.
Yep.
Which will be I got 2.024.
0.24. Alright, 2.02 to 3 sig fig, but alright. And we get 2.02 centimeters. There we go. Upper quartile minus lower quartile. 0.75 minus 0.25. 3/4 minus 1/4. Great. Any questions there?
No.
Part B.
Oh, so I'm just doing tail left and same stuff.
What stuff?
So then infinity and quartile range, just putting the area 0.75 and 0.25 and subtracting both answers from each other.
Yep. Let me just see. Do I only have the final answer? Yeah. So you put in 0. So I did it a bit of a different way. I said the tail right 0.25 and tail left 0.25. I want to try tail central. Just want to see what happens. Tail central. The area for the interquartile range, what's it going to be?
0.5.
Yeah. What was this one? Deviation 6. 72. There you go. Huh.
Yeah.
I never knew that. So let me copy that. Okay. So that's another way to do it. So it all comes from the visualization of the thing. Let me see. Copy that. I just want to even see, because there is a way to do it in the calculator. If you press down, I think, execute.
Are both answers acceptable?
Which,
Are those two different answers, or
no. So if the actual answer is going to be 76.0469 take away 67.953.
right? Okay.
And that's the interquartile range.
Yeah. Okay.
And so it turns out it was 8.09. I did it. So we've been doing it as, see, it comes from these things here. So you could do 75% of the data is less than the upper quartile. But you can also do 25% of the data is bigger than it. It's the same thing, gives you the same number. And that's what I was doing. But actually you could also do 50% of the data is in between these two in the middle. And that gets you there right away. Interquartile range. The 10th to 90th percentile. How would you do part B for this one?
So is it just same stuff basically?
And so what would you put in?
Okay, so so I think I'm gonna put in tail left area 0.2.
Part B.
Oh, sorry.
And it'll be tail right 0.2 for part A because it's greater than.
Yeah. So is that just the same as 0.9 and 0.1?
Yep. And what is 0.9 minus 0.1?
0.8.
I just want to see if my way works now. Central 0.8 to 60. Yep, that gives you, and you just do the second one, take away the first one. 62 take away 57, it's about 5. And that was 5.13. Yep, that's great. So upper quartile minus lower quartile. In this case, it was 90th percentile minus 10th percentile, or whatever you call it. So it's a bit different. Here you go. It's between 20 and 80. So I think that's going to be 60, 0.6 for central, whichever way you want to do it. So it's a little bit of stuff. Yeah, inverse normal. What do you give yourself?
Nothing overall, maybe a 2.
So we got 2 stuff done. Great. So normal distribution is not easy, but we're doing great. Yeah, how was that for you, Andrey?
Yeah, that's good, thank you.
And so mechanics again next time?
Yes, please, yeah.
Okay, and just to recap the other thing, you get to get the probability for the binomial thing first. You first have to get the normal, use the normal distribution to get the probability of 1, and then you use that probability in binomial because it's either a pass or fail or whatever. So it's very common, that type of question. Yeah, just take some practice. Yeah, any questions for me in general?
I don't think so.
All right, well done, Andrey. Have a nice weekend, and look forward to talking again next week.
Yeah, cheers. See you on Monday, I think, yeah.
I think it is, yeah. All right, take care. Goodbye.
See you. Bye.
Bye.